Hello everyone, I hope all of you are doing great. In this video, we will actually try to explore how I have implemented the DevOps pipeline and also the automatic deployment of the entire architecture using CloudFormation. So here the architecture you can see is architecture of a project, and this project actually uses the serverless components of the AWS for making the architecture and finally deploying an application by going through the green blue deployment process. So here the one component of DevOps is automatically deploying the entire infrastructure using the cloud formation, and the second part comes with GitHub Actions where we automatically push the code, automatically shift the traffic from the green to blue with the passage of time, and also immediate rollback from the green to blue when we actually see there is a breaking changes in the green that we have missed during our test cases or during our review process inside the GitHub. So without wasting any time, if I go back to my cloud formation, you can see my stack here, and all the resources is just being created in one shot. Okay, and now what I will do is you can see most probably that right now there is something like this, and if I wanted to deploy, because earlier there was a line which is like an initial deployment description line inside the API deployment, but I have just removed that line. So if I try to deploy my new changed architecture, okay, let's see what happens. I just have to give the run deploy command, and as soon as I give, you can see that my CLI has started to change my architecture. And if I go back to the AWS and refresh, we are seeing that my stuff is being updated. And if I refresh the events, so from this point you can see an update was in progress. And after that, I think this create complete actually took place. So if I refresh again, so yeah, so the update was completed and all those stuffs was also completed. And now we have our architecture back. So in this way, we can make just subtle changes and try to upload our architectural file to just make changes to our file, and then the architecture will automatically be uploaded. Now it's time to show you how I have actually implemented the auto push feature. So for that reason, I will just change it to version 15 for now. Okay. And before that, what I wanted to show you is if I go back and go to the Lambda function and reload, you can already see two versions right now. One is version 14, version 13, and it here the version 14 is the blue version because once it was green, but as it has 100% traffic, now from blue it has actually converted to from green it has actually converted to blue, because from the passage of time it has traffic shifted from this version to this version, and now we can see that the version 14 is the stable version. So if I go to my GitHub and come back to actions, then I will be able to see that my auto scheduling traffic. So earlier it was set to every 10 minutes. So every 10 minutes it was shifting 10% of the traffic from the blue version to the green version. And after some time passed, the version 14, which was the latest version, actually have the weight of 100% traffic, taking all the traffic to the latest version. So this is how I'm implementing the blue green deployment, but now it's time to see live how it works. So as you can see, I have made a little bit of change here. So what I will do right now is I will commit this change. Did a dummy change for showing in YouTube is this is a good commit. And this decommit, what it does is it stages and also performs the final commit at the same time. So the decommit is a custom command made by me. So let's check what happens. So we are done with the pushing, so maybe we have to rebase up to date, and then maybe we can push with force. because I don't want any previous changes to be existing on the remote branch. And after I pushed, I can go back and you will be able to see that I have already one pull request open, which is showcasing the auto push and auto scheduling in my YouTube channel. And you can see that automatically the test is running as I have made some changes to my code in the dev branch, and my all the test cases pass. So if I go inside it, I can see that it has run the integration and unit test, and we can also see that two pass ran two tests across one file and all of them passed. And we can also see a small test coverage here, which is saying that we don't have test coverage of all the functions. So we actually have to write more code to improve the test coverage of our repository or whatever you say. So now what can I do is go back to pull request, and this pull request actually also require a one manual review. So for that and for the sake of simplicity, I will go just now for my other account, and then what I will try to do is go to the file changed, and I will try to submit a review and approve and then submit the review. And once I submit the review, I can go back to my main account or the account which holds the actual repository, and then we can see that the manual check is done. Our test case all test case has passed, and now I can, as an admin of this repository, only I can merge the feature branch manually to the main branch. So I'm gonna do that. So once I did, I can see that my pull request was successfully merged and closed. So now if I go back to my main branch and try to see the code here, which is from the source and index.ts. So I can see here version 15, right? And now if I go to action, so we can go to the auto deploy AWS, and here we can see that did a dummy change for showing in YouTube. Okay, so this is the last comment that we have made right now. Okay, and it has ran just 24 seconds ago, right? Like now, and it has taken 24 seconds of time to execute. So if I go inside it, what will I see is a deployment job, and inside we can see that publish code automatically to Lambda. Okay, and here we can see a statement that new deployment of version 15 as green, blue version 14 now has 50% of the traffic. Okay, why 50% of the traffic? So if I go back to my code, okay, and come to GitHub and in the scripts and in the push, you can see I have 0.5, so that's why it's 50%. Okay, if I want, I can also start from 0.3, which is I think a little bit better, but for the showcasing purposes I have given 0.5 because I have to also show you the traffic shifting when I call the API, right? So now we have to actually wait for a long time, which is only 2 times a day this scheduling will happen. So if I go to the workflows and auto scheduler, you can see that every day at 10:30 p.m. and 10:30 a.m. this scheduling will take place, which will actually do the traffic shifting. But we also have a manual workflow dispatch. So what it will do is also let us manually shift the traffic and trigger this workflow manually if we want. So now if I go back and come back to the lambda function and reload, now you're seeing 14 13, it will become 14 and 15. Okay, so you can see that 14 and 15 and both of them have 50% and 50% traffic. How beautiful. And as soon as I just push the code into the main branch, I have to do nothing. These settings and all of the things and new deployment changed automatically, right? And now we can understand that we really don't have the time to wait for so long in this single video. So what I will do is go back and come back to my workflows. And after that, I will do is the auto scheduling of the traffic. So now what I have to do is, as we cannot wait for so long, I will run the workflow manually by pressing the run workflow button in the console. And then I will see that immediately traffic shifting was initiated, and our auto scheduler is trying to auto schedule traffic. Normally it will actually only trigger 2 times a day, but now we are triggering it manually just to experiment if it works or not. So as we can see, it successfully passed. And if I actually go to the perform auto scheduling step, it's saying that green version 15 now 60% and blue version 14 is now 40%. So let's check. If we reload right now, we will see that our green version is 60% and our blue version is 40%. Great, right? Now the thing we have to check is whether it's really load balance and send some traffic to version 15 and some traffic to version 14 or not. So for that, I will open my Postman, and after that I have the root here, okay, and I will try to send. And actually you can also see I have switched on all the headers to turn off caching, because sometimes caching introduces problems when we are testing load balancing. So if I try to send right now, it is saying that inverter version 13. Okay, no problem, we will try to send it again. See, 15. And now it will actually gradually shift between 15 and 13. But it really depends. There is no consistency, but see, now we are getting version 13 again. So it really depends. It's not like that. Now again we are getting version 15. So we have a rough idea that okay, our traffic is being shifted from both of the versions right now, and few traffics are coming to our latest version, which is version 15, which is the 50% of the traffic right now, and the rest 50% of the traffic is going to version 13. So if you try to execute again maybe, and yeah, we are again getting version 13. So we can see that it is actually juggling between the two versions, the version 14 and version 15. And whenever, oh sorry, that's why we are getting the version 15 more, because version 15 actually now had 60%, not 50%, my bad, due to the scheduling, and the version 14 was only 40%. That's why we are getting the version 15 more and version 13 less. So that's the thing. And now the thing is, like, suppose we have introduced a bug in the version 15, how do we roll back? We will come back here, go to our GitHub Actions, and then we will say auto rollback, and I will try to run the rollback here. So as soon as I run the rollback, you will see that all the traffic that is going to the latest version right now, which is version 15, will come and join the version 14. So version 14 will become 100 and version 15 will become 0, because we don't want any traffic to go in the broken version, right? So let's trigger the workflow and wait for the rollback, right? So I will try to reload, and here is our action trying to get executed. And finally we are done within 13 seconds. And if we see perform rollback complete, traffic shifted 100% to blue version 14, 0% to green version 15. So let us check by reloading it. So you can see that the version 14 right now has 100% of traffic, and the version 15 actually right now has 0% of traffic. So yeah, that's the thing. And suppose now we have fixed the version 15, okay? So if we fix the version 15 and then upload the new code, it will again become version 16 and the version 15 will stay there. So that's how actually we are implementing blue-green deployment. I hope you have liked the video, and thanks for watching, and I will see you soon.